The previous table showed what happened if either the supply curve or the demand curve shifts. Life gets a little more complicated if both supply and demand shifts, but we can still make good progress. If two curves shift, you can predict either price or quantity, but not the other. For example, if both demand and supply increase, the equilibrium price increases because the equilibrium quantity increases with both changes. However, the equilibrium price could increase, decrease, or remain constant. The equilibrium price increases when demand increases, but the quantity decreases when supply increases. An increase in quantity coupled with a decrease in quantity leads to an uncertain outcome in quantity. Therefore, if the demand effect is bigger, price increases. But if the supply effect is bigger, price decreases. And if by some strange coincidence, the supply and demand effects exactly cancel each other, the equilibrium price would remain constant. The graph below shows three possibilities. D1 and S1 are the initial price, or the initial demand and supply curves. So there's D1, and there's S1. That's the initial, which gives the initial price P1 and the initial quantity Q1. Supply increases from S1 to S2. We can see that nice and easy. There's S1. The supply increases to S2. However, demand may increase either to D2, D3, or D4. What happens to price and quantity depends upon whether the demand effect is bigger, smaller, or by happy coincidence, just balancing the effect on supply. So let's see here. All right. Suppose the demand increases a lot. There's a big demand effect. In that case, price will rise from P1 up to P2A. The quantity, as we know, is going to increase. Supply increase makes quantity rise. Demand increase makes quantity rise. So the quantity goes from Q1 to Q2A. If the demand rises to D3, we wind up with a happy coincidence that the price starts at P1 and it winds up at P2B. Price doesn't change. The increase in supply made price fall. The increase in demand made price rise. And by happy coincidence, they cancel each other out exactly. The net result is that price remains constant. This is an unusual and unlikely outcome, but it could happen. It also means that the price change could be pretty darn small. The third thing we're going to study is what happens when demand changes just a little bit. So the demand effect is now what I'm going to call small. In that case, the price starts at P1 and it falls to P2C. Again, quantity goes up when supply increases, and it goes up again when the demand increases. The net effect on quantity is always going to be to increase quantity when supply increases and demand increases. Here's a table that summarizes the possibilities. When demand increases and supply increases, quantity increases, but we know what happens to price. Demand decreases and supply increases. We don't know what happens to quantity, but we know price will fall. Demand increases and supply decreases. Again, we don't know what happens to quantity, but we know price will rise. When demand decreases and supply decreases, the quantity will decrease, but we don't know what's going to happen to price. Another thing we can do with supply and demand is we can infer what happened to supply or demand from observing market outcomes. We can infer what happened to demand and supply by observing changes in prices and quantity. For example, if both price and quantity increase, the analyst can infer that demand increased because both equilibrium price and quantity increase when demand increases. On the other hand, if price increases and quantity decreases, the analyst can infer that supply decreased because the equilibrium price increases when supply decreases and the equilibrium quantity decreases. The table below summarizes possibilities. If both price and quantity increase, that looks like an increase in demand. If both price and quantity decrease, that looks like a decrease in demand. If price rises and quantity falls, that looks like a decrease in supply. And if price falls and quantity rises, that looks like an increase in supply. Oops.